the other thing is we're going to want to have the speakers give their 20-minute presentation, and then we'll save our questions for a 15-minute session afterwards, just so we can stay on time with each of the presentations. So you can either type your questions so you don't forget them while they're giving their talk in the chat, or you can take notes and then ask them live. It's whatever you guys prefer. And then we will have a session at the end just for discussion and being able to discuss back and forth where we need to be going with this technology to get it more widespread in use. So with that, I'm going to get into a brief overview of we have a pooled fund that we Minnesota Department of Transportation is leading, but we have a lot of active states, and Federal Highway has been really helpful. So we had an event last week and we gave an update on the progress of the work plan and some of the things we've been working on through that pooled fund. And the goal of that pooled fund is to get DPS technology, both the technology that the speakers will be speaking about today, as well as our methods that we use to implement the technology, and some of the other things like precision and bias statements and operator certification. All those things are a subject of the pooled fund, and we're working on those on that end to try to get all of our procedures and AASHTO specifications in place so we can take this technology and use it as a density acceptance tool. So I just wanted to briefly, I'll share my screen here and give an update on kind of what went on with the meeting, where we're at based on that meeting from last week. So you should be seeing an agenda right now for the event today. And what I did, I just put a few of the slides or the title slide for each of these different talks, just so I can get everybody up to speed on what was discussed last week and where we're at with the DPS through the pooled fund. So like I said, we gave an update on the work plan progress, and Dr. Shangtao Dai did a great job with that. And one of the main things, as I said, with that work plan, in addition to the operator certification and precision and bias, is getting an AASHTO specification for use of this technology as an agency for density acceptance. So that's was a big focus of the morning session, and I gave a presentation on the current protocols that we're recommending through the pooled fund for that, which will become an AASHTO specification eventually, and then also some of the information that we're posting on our website, which I'll give a link to when I'm done with my update here. We also are excited to have University of New Hampshire and also Adam Hand from University of Nevada joining the team, and they're going to take I guess a fine-tooth comb to our protocols and also try to add a little bit more justifiable statistical analysis tools that'll kind of put in our mind this technology over the top in terms of our ability to justify its use and what actually needs to be done from a protocol point of view to be able to use this technology to accept asphalt density in hot mix asphalt. So they did an awesome job presenting some of the work they're going to be doing, and then they're also going to develop a couple technical briefs that'll help get people up to speed in what DPS is and what it can do for density analysis. I gave a presentation on some of the stuff we're doing at MnDOT for our data collection and analysis, and the focus on that was a lot of the real-time analysis that you can do when you have the technology out there, but then also diving a little bit deeper in how we're checking the accuracy of our DPS predicted density versus what the cores are telling us out there. And then also, once you have this conversion from dielectric to density, presenting a new kind of on-site type tool where you can actually export summary statistics that give you percent conformance of the asphalt pavement, and all of this stuff was posted on our website, or will be posted on our website, so you can get details of all these different presentations by going to the DPS Pooled Fund website. NCAT is doing a large study. They're working on operator certification and equipment certification type activities, as well as precision and bias, and looking at some of the more detailed analysis, like looking at how deep or how shallow the lift can be and still get a reliable dielectric from our surface reflection. Day 2 was a little bit more of a peer exchange than a project update, which was awesome. We got to get really good information on what the states are doing, and I just wanted to give an example of how quickly you can get up to speed with this technology. This is New York and Ohio are some of the kind of more advanced users. They've been using DPS for a while now and using it quite a bit. And North Dakota has just started to ramp up their efforts and collected a lot of data this construction season, and they're already outputting density and Veda, which is a tool to combine DPS data with some other intelligent construction technologies. And Rebecca's group here at MnDOT helped them use the DPS and integrate it with some of the other intelligent construction tools out there. And I think this is temperature of the breakdown roller there presented. It was really great to get the contractor perspectives last week. So we're looking at it from a density acceptance point of view, which requires a lot of different steps that we talked about later on day 2. But it was great to see contractors like Matt Oman with Matthew, and then also a consultant, Bryce Worry, who works with a bunch of contractors. You see all these different projects from different states that he was on, where you can also use this technology as a quality control tool for contractors, either looking at test strips to get your rolling patterns, that sort of thing. So that was great to hear from both Bryce and Matt, as well as Mitch Froelich from Minnesota. Steve Cooper, who's really been a champion of this method for years now, gave a good highlights and summary of a planning workshop that Federal Highway put on. And that included, in bold here, I included this slide, a number of gaps identified, which we might want to discuss later today. And then Dennis Dvorak from Federal Highway and myself went through some of the challenges that we encounter trying to get DPS for acceptance, and some potential solutions, and what it looks like from core elements of your quality assurance program point of view. So overall, really successful couple days, I thought, and ties in well with what we're trying to accomplish here, where we're getting the vendors and the users together to try to discuss some of these things. And before I take any of Kurt's time here, I just wanted to leave you just with a little bit of perspective here that our office director, Glenn Engstrom, always gives with new technology, that we need to make sure when we're evaluating this technology that we're not holding new technology to a higher standard than the existing methods that we're applying. So in this case, you know, we're comparing what is being presented here and where we're trying to go with this technology to the current state of the art, which a lot of times is spot checks with cores or a nuclear density gauge. So this is really exciting stuff that brings challenges, but it also brings a lot of opportunities. So with that, I'm going to pass it to Kurt Turgeon. He's MnDOT State Pavement Engineer. He's also a chair of an AASHTO committee that's critical to implementing a lot of these new intelligent construction technologies through the use of AASHTO specs, and also has a lot of experience with these user group meetings. So I wanted to let him give a little bit of perspective here before we get into the presentation. So go ahead, Kurt.
Okay. I guess one of the things I want to remind people of is back in the Sharp 2 program, this technology had a sister, which was the thermal imaging behind the paver. And thermal imaging, and we've fully implemented that. All of our paving projects have thermal imaging. A lot of the county projects have thermal imaging. That started out with an idea in the Washington DOT, where they wrote a spec where they took a handheld temperature measuring device and took a measurement 1 foot apart, and they decided that, you know, the high to low was an indication of something going wrong with the paver. They also realized that doing that right by a paver stop was not a good thing, because paver stops kind of screw up the temperature profile. So that idea made its way to Texas. Texas DOT started playing with it. TTI showed up and said, well, why are you walking along doing this? We can automate that. So they built what's referred to as the PavIR bar, put 12 sensors on it and a bunch of wires, hung it off the back of the screed, and this new technology of thermal profiling was sort of created. TTI doesn't sell stuff. They talk to MOBA. MOBA is a company that builds things that hang on pavers, a lot of sonic sensors and other things. So they're used to dealing with low bid asphalt contractors. So this PavIR bar came out, and we've been in contact with Washington and Texas as this is going on. And we say, well, when we look at the Sharp 2 stuff and say, well, we're going to do this. And we had some money that was, you know, go out and do something innovative. So we started writing change orders on projects, telling contractors, buy this thing, hang it on your paver, and we'll all look at the data together and see if it tells us anything. And that's kind of where we're at with the DPS. But what happened with the PavIR bar is the thing's in the way, the wires are bad, the connectors are bad. We hate this thing. You got to stop this. This is terrible. But we kind of just push forward. We were in a little bit of an unfortunate in that area, in that MOBA was the only one building things. So we kept saying to MOBA, could you jazz this thing up a little bit? And it's like, well, you know, we haven't sold enough of them to really start spending money doing those kinds of things. Now, fortunately, eventually, MOBA figured out that bar behind the paver with all those wires and all those sensors was just not going to be durable enough, and it was not going to suit the day-to-day operations of your typical paving contractor and their crews. And that's kind of the thing we got to remember is who's going to ultimately be using or deploying this technology. They may not understand the data, they may not understand why it's being done, but we got to have something that's simple enough and easy enough that your paving crew people can do this and make the data come into our system so it makes sense. And that's kind of the feedback. We had some feedback from the two contractors as separate meetings, and that's kind of what we're hearing. We're at this point sort of with the thermal where we put the bar out there and said, use it. And the feedback we're getting is, well, you know, you got the science figured out and you understand how it impacts paving, but you don't have this in a format that as a contractor, I can hand it to someone in my staff and have it do all the things that you at MnDOT want it to do. And that's really the conversation that has to happen. And one of the reasons why we sort of pushed this year to try and have the contractors rent equipment. So that conversation between the person who's, I mean, ultimately they're going to be buying the equipment and they're the ones who are going to be saying, I need parts, or I mean, the durability of the PavIR bar was not good. And they came in and said, you know, MOBA builds good stuff. It usually works, but when they built this, you know, they cut some corners, or they made it cheap, or they just sort of copied whatever TTI had given them. So it wasn't even up to MOBA's typical standards. But that's kind of where we're at now, is to have, we got the science figured out. We have all kinds of options in terms of specifications, and do we scan the whole lane, or 100 feet or 200 feet, skip ahead, all those kinds of things. Those will all come together eventually. But one of the things we got to be a little careful of right now is, so way back when Washington said, we're going to skip paver stops because it made sense with how they were doing things. One of the feedbacks I get now from other states is, why do we always, now that we have this thing that's automatically collecting all of the data continuously, whether the paver stops or not, why are we skipping paver stops? And it's kind of like, well, that's where it started, and that thought that paver stops shouldn't be looked at has carried through all the way till now. So, I really think that's where we're at right now. We're never going to get low bid asphalt paving contractors excited about buying another gizmo and having another person on the field there. That's a given. We'll get past that if we can make this function in a way that they can hand it to somebody in the field, and we're confident that what we're getting is the right stuff. And they don't end up at the end of the project going, well, what do you mean you're not paying me for collecting the data? That we did what you told us to do. So we've had issues like that as well. So that's my perspective, is we got to kind of broaden the audience and get more feedback on making this doable, more practical in the field.
Yeah, great stuff, Kurt. And Kim, I'll be monitoring the chat throughout this. And Kim Schofield said, great history, Kurt, and great lead into what we're trying to accomplish, which I think we should save some of those thoughts for later. I think that'll lead in really well to some of the discussion we want to be having about this technology and what we need to do moving forward. With that, I think we're pretty well on schedule to begin with the vendor presentations, and we'll start with 3D radar. Jacopo Sala's been great to work with in all things GPR, so it's great to have him with us today. We're starting around 12:20, and we have some flexibility in our schedule, so you got until about 12:20 Central Time, so you still have your 20 minutes, Jacopo, and with that, we'll let you share your screen and get into your presentation.
Right, great. Thank you, Kyle.
It's the upper right. It's the upper right and the arrow that points up to share your screen.
Should see something now.
Yep.
Excellent. All right. I'll be honest with you. I haven't timed my presentation, so go either way. I'll
be right. I'll be on your time limit here, Jacopo. So don't worry about that. I'll give you a 5-minute warning. How's that?
That's fine, but I think it should be fairly lean. Well, let's just go. And I would like to start from where were we, because I had a little bit of trouble myself in remembering when was the last time and how did I address the group the previous presentation. And due to this COVID thing, you stop traveling, everything is frozen, so it's a little bit of a strange feeling. But I think I dug the last, and we've done a lot of activities in the meanwhile. So it's very good to be able to present an update today. And I think I found these 4 slides just to give you an idea where were we the previous time. And I think the previous 2 meetings that we had was January 2020, and that was the last time we met in person, actually. Or somebody was virtual still, but it was during TRB that year. And then we had a small follow-up in April the same year within a series of webinars that were organized by FHWA. So what these 4 slides say, so there is one slide to have 4, and I was listing the objectives that we have that still remain. So the dielectric profiling available as part of a standard system operation. So we are not building a system that is 100% on that purpose. So we are using our system, our array system, to also perform that task. we want to be able to be sure to collect, to focus on big data, near total level data collection at least. It's an array system, so full lane coverage, and we want to have high sampling in both direction. Then I was listing the activities that we had done during 2019, which was a very first prototype software to do very quickly a calculation that could lead to dielectric values, and therefore we're with the idea of then converting everything to density, but also embedded in that is how do we calibrate the data in terms of having a metal plate 100% reflectivity reference. How do we do the reflectivity analysis and so on, and then how do we go on with testing? Then we, after there was some images being shown, and this is what we've done, and we came up with some challenges that we wanted then to solve. So the mechanical aspects, what happens because our system is vehicle mounted. So you have a lot of potential movements from the vehicle itself, from traveling at the traffic speed, the mount of the system itself, and then there are also, of course, signal aspects like what happens when you have interference, how much does it impact your data, and how do we want to use the calibration data? Should we refine the calibration procedure? And by that I mean not with the core samples. I mean the calibration. Meaning passing from just amplitudes to reflectivity and therefore dielectric values. And then I went through some activities forecast, which required a lot more testing, a lot more algorithm development, and then creating some standards, some procedures, a workflow, and then arrive at least at an implementation within our software. So visualize the things within our commercial software. That's where we were, and that's what we've done the next, let's say, couple of years up to now. We have finalized software algorithms, so we have a fully working prototype right now to arrive at the dielectric values, and it's fully automatic. There is also potential for real-time, 100% on the way it operates, so doesn't require you to do any specific operation. You just get the data and the thing happens by itself. And it is the algorithm is really focused on our kind of technology, which is step frequency and array. So it's 3-dimensional and frequency domain type of radar. And I don't want to go through the thing right now, but by all means, if you have questions about that, I'll be happy to answer them later on. And we have also integrated this into Examiner. So it's still a prototype, so it's not available if you install Examiner today, but we were able to embed it into the standard processing workflow, all right? And with that, I mean also the visualization and so on. We have gone through all the workflow specifics in terms of, how do you collect the metal plate data, this 100% reflectivity, and we really wanted to have this kind of data collected at factories during when we create the antenna. So we've done a lot of testing associated with this. So what happens if you use, 100% reflectivity data, which is 1 year old, and we've done it, and the thing works well. Because of the nature of the radar and because of how we programmed the entire thing. So that was very good. We were very happy to see that. Of course, you need to recollect this data if, for example, you need to repair the antenna, or I guess after a while, but we haven't arrived at 3 years testing for now. So it's that's where we are. And we were also able to create a standard for data collection, meaning if you can go up to, for example, 45 miles per hour, which roughly is around 70 kilometers per hour, if you really have to, but with still a very dense grid, 3 inches by 3 inches, and using a fairly wide array, 2.1 meters, which roughly is 7 feet, and with the effective scan width a little bit less than that, count between 6.5 foot to 7. And we partnered up, or we collaborated with Teratech, which is one of our customers here in Norway, for letting them play with the thing. They were very supportive. They really wanted to go out and test this methodology. We got in touch with them, or they got in touch with us too, regarding the same thing. And we gave them the algorithms. We make sure that we explained them the best way we could, how to use the thing for now, still being a prototype. And they went out and participated in pilot projects and done a lot of testing by themselves. So we wanted really a third party to collect some data and do some processing and come back with some feedback. So we differentiate a little bit, as you might have understood, as compared to the other technologies that you're going to see, to the other types of equipment that you're going to see. We do more, we call it internally dielectric mapping more than profiling, because what we produce is a three-dimensional image, or a two-dimensional image that is extrapolated from a three-dimensional data cube. But we really focused on a different kind of solution, so because it adapts better to our system. So we still wanted to be vehicle mounted and have data collection at traffic speed, cover the entire width, as much width as possible, and to make it available as a standard or within our tools for data collection and so on. So it means that when you collect data for doing dielectric or density profiling and mapping with our system, you still have available the rest of the three-dimensional data set to perform the standard operations like layer tracing, mapping of cables and cracks and so on. This is the type of image that we arrive at having. So the one on the right-hand side, I believe that it provides for a more, or it gives a chance to have a more intuitive way to interpret these results. So this is part of the test that TerraTech has done, so collected with our system, and they were very curious about this one. They thought it was one of those, paint marks, an arrow to turn, but actually we were able to dig from Google Earth, Google Street View. On the left-hand side, actually, they did, by chance, that image was collected very close to when they had paved the road. And we noticed that there was that mark, which probably indicates a much a higher compaction area, probably because that's probably the couple of tires marks that were there. And it is pretty much one-on-one with the data that we get. So that was very nice. What kind of advantages also does it give to have a cross-line sampling, which is similar to the inline sampling? Well, you get an image that is the same resolution one way or the other. And therefore, for example, you can also trace. I don't know if you can still see my screen because my screen is going a little bit. Cal, can you see my screen?
I can see your screen, but I don't see you scrolling anywhere. Are you trying to show a certain spot on the picture?
No, it's just that my monitor went black for a second, so I wasn't sure that you guys were still, for example, now. But if you can see it now, for me, it's fine. I can just maneuver from the left-hand side.
Okay.
All right. Anyways, it means that you can map also longitudinal joints without necessarily moving the equipment from left to right in the road. You can collect those data at the same time. And by the way, that image on the bottom right, that is the dash cam of the TerraTech truck. So they were moving with traffic. So the data set that you see, the results that you see on the left-hand side were collected at traffic speed. This is not a new paved road, but this was part of the testing. I'm going to show some data out of that because it has some very recognizable features. To show you that the algorithm accounts for all the bouncing and everything else. So the algorithm and the calibration procedure with 100% effectivity. Other things that are visible, for example, transition between newer asphalt to old asphalt and vice versa. Joints across the road are also very visible, of course. It's possible also to see a sort of phenomenon that happens pretty much here in Scandinavia, that you have a lot of rutting due to the fact that they have studded tires during winter. But this does impact the results, so this was interesting to see. This kind of focuses the waveform coming back. And we really get a very nice level of detail. So, for example, this was a roundabout, and you can see on the bottom, you see that we are transitioning from newer asphalt to the older asphalt in the roundabout, and as expected, the older asphalt has a lower dielectric constant. Within the roundabout itself, you can see that we get those waves, which is really how the roundabout was paved. So the longitudinal joints, but curved due to the fact that it's a roundabout. And at the exit of the roundabout, the high resolution gives you also the possibility to understand whether you're having a variation due to an actual feature of the asphalt, or whether you have, for example, a crack. And that was also very good to see, that we get those tiny results up on the screen, tiny features. Then, apart from driving in traffic, TerraTech has also been doing some pilot projects, as I was mentioning. These are still under analysis, so I can show you some stuff, but without really telling you where or how or who. But here in the Nordics, in any case, and they've done some testing in newly laid asphalt, and they've done static tests, they've done multiple passes, and they are now in the process of finding a correlation with enough cores. I'll be talking a little bit more about that kind of soon. And these, for example, 3 different scans obtained on the very same area, and the results are very, very similar, if not identical. There is some variability, perhaps you cannot even see it, but there is definitely some variability. Some of it we know why it happens. Some of it is due to simply some error, some biasing error in the algorithm in creating color maps and such. But I can say that I'm fairly happy with the results, and I'm very happy to see how the channels, the different channels, so different antenna pairs, transmitter and receiver pairs across the array are performing and giving back as a result. So now going towards the closing this already, as a matter of fact, so I've been maybe fast, but I think the good news for us is that TerraTech has done a very, very good job in trying to estimate the accuracy of the method, and they found the accuracy to be very, very good for both rolling measurements, so while driving, and standstill measurements, static measurements. And they, based on the standard deviation that they're seeing, they are seeing a variation that is as tiny as 0.02, 0.04 in the electric value, which works very well for them. I believe it works very well for us. For what I know, should work very well for you guys too. I'm open to any kind of input in the sense. And I have to admit that they have kind of forgotten they were using a prototype most of the time. In fact, most of the feedback that I got was related to, how do we improve the usability and on the GUI level, but there is no real GUI for now on the software. It was more, a very prototypal GUI that would let you decide some parameters, etc., just to make it a little bit more maneuverable at this stage. But in terms of the results they got, it was very practical for them to use. It was very they have a very good feeling for it. So I was very happy to hear that. Most of their variations that they see, so where does the equipment escape that accuracy? And these are areas where there is very high electromagnetic interference, and that's definitely a problem, I guess, for GPR in general. It can pose a bias to the results, even if you try to suppress it, interpolate it. You need to have a little bit of smart methodologies to do it in an effective way, and in an effective way that doesn't create any bias later on. So for now, the algorithm that we have implemented does not include any interference suppression. We did it kind of on purpose so that we could study this and we could know how much it would impact the results. And thanks in particular to the data that we have collected downtown, so in very noisy environment, then it's something that we can work on. And we have a couple of ideas on how to introduce it in the workflow too. So that's the next one of the next things to do. The conversion to density is still an ongoing process. The cores, unfortunately, the two pilot projects that they had where they could collect cores at the same time, the asphalt did not offer really much diversity, so it was very, very similar. The graph on the right-hand side is the only one where we had enough variation in the electric and variation in the density, or the electric was different. You know, we had variation in the map, and it was confirmed via cores, and the cores offered a bit more of a jitter between minimum and maximum, but still it was just for a very tiny section, unfortunately, very small section of a certain type of asphalt. And I'm not sure it's well, it's not enough right now to perform a statistical analysis and tell you, yeah, it correlates extremely well, it correlates not really well. So that's still ongoing. They probably need to collect more cores and explore more locations. If you want, the good news in these is that they understood it the first day. So when they were out collecting the data and they processed it and they saw the images that the system generated, they immediately told to their customer that they wouldn't have had enough variation to produce meaningful results. So they cored a little bit, according to the results, they cored in some points, and it was the points were almost one on top of each other. So not much to do, not much to do at fitting. And again, in general, the prototype and workflows work better than I even expected. So far so good, I would say.
Thank you very much, Jacopo. That was, you've made some good progress since last time we talked, so thank you for that. And then Irv had a question in the chat box, and it looks like Di just had one. We're going to save those for afterwards, but at this point, I think we better move to Chuck to stay on schedule here. And Chuck, you're starting at.
If you want, this is the absolutely last slide. So.
Sorry. I thought you were done. Go ahead.
Now, these are the next steps. Just 3 points. So we want to introduce the interference suppression mechanisms. We want to introduce a GUI to do the density conversion so that we also help in TerraTech's next step. And of course, more testing, more people involved. And as I promised you, it was the last one. So thank you for your attention. And I would also like to thank TerraTech for carrying out these tests.
Very good. Yes, nice job. Thank you, Jacopo. So we'll have those 3 questions in the chat, and we'll save those for later. And for now, we'll pass the ball to Chuck, who's been also very active with density profiling systems. Had a lot of good conversations with Chuck, so I'm excited to see what Chuck Oden has to present here. And then at the upper right corner to share your screen, there's an up arrow.
Upper right corner. I have the web version going.
Okay.
Oh, here we go. Share tray.
And then you have to pick which one you want to share. Yep. Okay, it's sharing the screen. There we go. Perfect.
This one.
Yes, thank you, Chuck. Take it away.
Okay, well, good afternoon, everybody. First off, I just want to say I have a terrible head cold that I woke up with this morning, so hopefully my voice will carry through the presentation. So please bear with me. Last time I presented to this group was at TRB a couple of years ago, and so there's a number of improvements that have happened since then. And for those that may not remember our system, our asphalt pavement scanner is a single-headed rowing cart. Can people see my mouse cursor?
Yes, but it seems to be moving a little bit delayed on my end.
Okay, okay. We have a push cart with a single scan head on it. We can pull the push cart behind a vehicle, and we can take the scan head off and put a coupling cone on it and use it as a gauge. So it's got pretty flexible configurations. And this is the device measures dielectric constant, just like everybody else is doing. You know, we're conforming to the AASHTO standard, and with a suitable mix calibration, you know, we can get compaction and density, and that's you know, literally the $1 million question that we're the thing that we want to really investigate a lot more, and I'll have a lot more to say about that later on. But this device also measures a few other things as well, such as asphalt thickness. It is a GPR after all. We measure the roughness of the pavement, and we have an IR temperature sensor. So we've really tried to make this device really easy to use. You know, the shipping case, you can see the shipping case in the lower left there, and you can have it unpacked in about 2 minutes. You pull the card out, then you take the scan head and you attach that with some thumb screws, attach the handle, and then finally the tablet, and you turn it on. So there's no cables. With everything that we've done here, we've tried really to get rid of all cables in all parts of the system because we just think that they're weak links. And I will mention that we've gone through a couple of changes on the cart over the last couple of years. We had some complaints early on with an earlier version of the cart where, you know, part of the calibration procedure is to lift up the scan head to essentially record the background waveform. And we had a movable arm that had a push pin, and you had to pull the pin and move the arm up, and you know, that seemed a bit cumbersome. And so we improved that arm, but even that was a little bit cumbersome. And so what we're doing today is just simply push down on the cart and raise the scan head like you see over here. It's very easy. There are accelerometers in the scan head. So you push the button, it knows if you've tilted far enough, and it beeps at you. And so we recommend that people do a line calibration every time at the beginning of every scan line. And since it's so easy to do, you just push down, it takes a few seconds. You just do this at the beginning of every scan line. So, you know, GPR is a really interesting technology, and there's a lot of information that we can pull out of these GPR traces. So, you know, I think everybody here knows that we're measuring dielectric by looking at the amplitude of the reflected wave. Depending on which part of the reflected wave we look at, we can investigate to depths of 1.5 inches or 3 inches. And then by measuring the travel time between the scan head and the asphalt surface, we can measure the height of the scan head, or the varying height of the scan head above the surface. And from that, we can derive a roughness measurement. And since it is GPR, I'll show you an example of where we're measuring thickness, where we're looking at the travel time difference between the reflection from the top and the bottom of the asphalt mat. And then finally, as I'd mentioned previously, we have a temperature measurement. Okay, we've also made a lot of improvements in the positioning system. So there are two sensors for positioning. The first is the wheel odometer, very conventional, except that it is wireless. And we have a multi-band GPS that has a few different modes of operation. So in the unaided mode, you have about 1 meter accuracy. but we have a subscription. Users can subscribe to something called Point Perfect that works anywhere in the continental US and anywhere in the continental Europe, and we can get 3 to 6 centimeter accuracy with our GPS. And so that's anywhere. You do have to have cell phone connectivity for this to work. The tablet has a cell phone modem in it, and so we are downloading correction data from a server. But anywhere there's cell phone connection, we can get this precise GPS, and you don't have to be near a base station. We do have an RTK GPS configuration. So if you have some N-trip servers that you like to use, or you have your own N-trip server that provides RTK base station information, and that's available over the internet, you can set up the software to pull down this N-trip information, and you get 1 centimeter accuracy. But really, for this to work, you need to be within about 10 kilometers of a base station. And the reason we like Point Perfect is it just works everywhere. You turn it on and it goes. You don't have to reconnect to a different N-trip server for a different location. So we think this is a pretty neat feature. And the way we provide the systems, it just works out of the box. We ask our users to set up survey grid lines, and we typically do 3 lines per lane. Users can elect to do as many lines per lane as they like. Our spot size is about 24 inches wide, and so you can do a more dense grid if you like. And then for a 2-lane road like you see over here, we would typically do 7 lanes, or 7 lines, 3 in each lane, and then we always do a line right down the center along the joint. And I'll show you some of that data, and I think it's pretty cool. As you can imagine, the joint compaction almost always is less than the middle of the lane. Okay, let me show you some data. This happens to be a new subdivision going in on the south side of Denver, and normally we would overlay the data on a Google map, but in this location, Google Map just has an open field, so we just pulled the counties maps and overlaid our data there. And so this is temperature. When we went out to do this survey, they had already done some paving the previous day, and so you can see those roads are cold. But the 2 roads where that show the warmer colors, you can see some variation there, some yellows and some reds. And we don't know what these temperature anomalies really mean, but oftentimes, as most people here know, temperature anomalies correspond to problems like segregation. And so what this would do in the field is, if you saw this on your screen, this would just sort of flag an area where people need to go look and see if there is something like segregation or something else going on that would cause this temperature anomaly. I think that's all I wanted to say there. Here's compaction. And we'll look more closely at compaction. We're kind of zoomed out here a little bit, so it's kind of hard to see what's going on, but we'll look more closely at compaction in a couple other slides. You can see these 2 roads were done at the end of the day, and maybe they wanted to get out of there. I don't really know what's going on, but you can also see the line down the middle that, it's a different color. The joint just exhibits worse compaction, which is a pretty common occurrence. So let's look at this in a little bit more detail. Here, if we take all of the data, so we did 7, this is a 2-lane road. We did 7 lines on this road, 3 in each lane and 1 along the joint. If we take all those scans and put them, join them together, you can see that, the values for the joint are actually a lot lower. And the configuration of our card actually works quite well for straddling a joint between lanes. We're getting a valid measurement as long as all the wheels of the cart are on top of the mat. So we think this is a pretty valuable measurement. We do have the gauge mode. I'm not going to talk too much about that today, other than to say that you can pull the scan head off the cart and put this coupling cone on it and take some spot measurements, and you could do some joint inspection that way if you like as well. Here's a roughness display, and again, this is just derived by looking at the changing scan head height. And so this measurement is sort of similar to a dipstick profilometer. It's a little bit different. We started out wanting to make an IRI measurement, an International Roughness Index measurement, but it turns out our wheelbase really is a little bit too short to detect those long period undulations that would be detected by a larger apparatus like the California profilometer. But nevertheless, so we kind of back off at calling this IRI. We may try to revisit this, but nevertheless, it's a really good indicator. It is a measure of roughness, but it's not something that can be used for acceptance testing. And then, of course, thickness. It is a radar, and so this is a B scan. I think most people here have seen radar B scans. We can pick the this is the top surface of the asphalt. This is the bottom of the asphalt, and we pick this horizon here, measure the travel time, and can calculate the thickness. In this example, we can also see the subgrade here. And then you can see in the map over here that there are some thin places, definitely some thin places here. And so this is pretty interesting that we can get all of this information from the data that we collect from a single pass of the scan head. Okay, next, I think this topic is something that everybody is probably, the topic that they're most interested in, and that's how to move from dielectric constant to calibration. Or excuse me, dielectric constant to compaction. And we really try to use this mixing formula, the Bachelor mixing formula. It was originally, well, not originally, but Lang's PhD thesis from Illinois, really went through this in a lot of detail. And if we know the dielectric constant of our constituents and we know the volume fraction of our constituents, we can calculate the dielectric constant of the mix. And, this relationship is essentially linear. So really, we only need one, theoretically, we would only need one data point to come up with figure out which of these lines we're going to use. Now, there's no error with one data point. That we can't calculate, standard deviations or anything like that. So we like to have more than one data point to calibrate with this formula. But since inherently the relationship between dielectric constant and compaction is almost linear, we just use this formula, and depending on what we use to calibrate with, we can get away with just a few different points. So the method that we really like to use, the most accurate method, is to calibrate using gyratory pucks. And so this is the setup we have. We take the scan head off, and we put this long coupling cone on here, and we measure the dielectric constant of a gyratory puck. Well, the reason we really like this is there's a number of reasons. One, it's very accurate. We get a very accurate measurement of the dielectric constant of this, but we're also essentially testing with our radar wave the entire volume of this puck. And the entire volume of that puck is what is used when you're determining the compaction or density with some other method, with the standard laboratory measurements, say AASHTO, T312, or some other methods. So it's really an apples to apples comparison. The accuracy is very good, and with just a few gyratory pucks combined with the Bachelor mixing rule, we come up with a pretty good calibration, mix calibration. We can, a lot of people try to use gauges, and I'm not going to say no, let's not use gauges, but let's really be cognizant of the issues when using a gauge. So the volume of investigation of a nuclear gauge is, we'll just say it's a hemisphere of about a 4-inch radius, and that volume is really not so. The scale of that volume is really not so different than the scale of heterogeneity of asphalt, if you take a nuclear gauge, take a reading at a certain place, and move it over just a few centimeters, a few inches, oftentimes the readings change by a couple of percent. And so, if we use the gauges as our reference, and of course the gauge has to be properly calibrated, there's all the issues associated with that. But if we use that as a reference, we really need to have a lot of gauge measurements to sample the representative volume that is also sampled by the pavement scanner. So as I said, the pavement scanner footprint is about 24 inches wide. We cover a lot of ground with that single scan head. The non-nuclear gauges have a larger volume of investigation, but it's still quite a bit smaller than what is used by the APS. So really, I think this might be coming towards the end, but at the end of the survey, what are the questions we want to ask ourselves to ensure that we have a quality survey and an accurate survey? Well, the first thing we tell people is to do some repeat measurements at the same locations, and if the numbers are the same, of course, we would say that that's a quality survey. If they're not the same, let's investigate some of the reasons that the numbers might not be the same. Number one, we can talk about the calibration of the scan head. Our scan head, we've done a lot of work to put in a lot of temperature dependent calibrations, and we don't have to calibrate with a metal plate, but what you can do is take the scan head off, and we provide a dielectric standard, and you can put the scan head over this dielectric standard and make sure it reads the right number. And we haven't had any not read the right number to date, but you can verify that the scan head is actually measuring the dielectric constant properly. So if we take away dielectric drift issues, if you will, what else could cause the readings to change, repeat readings to change? Well, if there's water present and the temperature changes, we know that the dielectric constant of water is temperature dependent. And so, if the temperature of the asphalt is different than the first time you measured it, and then the dielectric constant that you measure is different, that's a good indicator of water. Or it could be an indicator that you have water and you have a different amount of water between the two measurements. And so, I guess I would take the position that, if you have some sort of indication of water, then we really cannot move from dielectric to compaction or density. There's one paper that talks about shrinkage, and that the actual compaction does change with temperature of the asphalt mat. I don't know enough about it to know anything about this, but I have read quite a few papers that talk about the fact that, the constituents, other than water, anything in the asphalt, the dielectric constant of the constituents of the asphalt are not temperature dependent. So anyway, these are just some things we need to look at to ensure that we've got a good survey, and we need to consider these things when we're looking at methods for using this for compaction acceptance. I probably should have put more pictures here. We've got a lot of different types of data outputs. We can generate maps and reports with histograms, percentage within limits. You can also import the dielectric data into Veda. And I think you can import our temperature data into Veda as well. I'm not sure if Veda has a way. Last time we talked with some of the developers, there was discussion on how the calibration information was going to be stored in Veda to move from dielectric constant to compaction or density. But suffice it to say that there's a lot of different types of data outputs, and we can output a CSV file too if you want to make your own plots. So that's really my presentation. I think we've got a very flexible scanner. It's very lightweight. It has 3 different deployment configurations, so that's a lot of flexibility, and I think this really is a rich data set that we're collecting. So thank you all for your attention, and thank you for putting up with my voice. I'm glad I made it through.
Yeah, it worked well, Chuck. I could understand you well, but I could definitely tell you had a little bit of a cold there, so thanks for powering through. Yeah, nice work. So, and we did get some questions, and we'll save those again for the end. And I think it's going to be Rob giving the presentation for GSSI as long as his hotel internet doesn't have any issues. So GSSI has been great to work with this technology, so we really appreciate their presence here today, and I'm looking forward to what you have to present here, Rob.
All righty, so I'm going to bring my presentation up. I'm going to share my screen. And Kyle, give me a yes or no if you can see my screen.
It might be coming, but right now it's it just shows frozen.
Okay. Yeah, everything was working well. The presentations were just coming in slow for me, so okay. That takes up the bandwidth. I may have Ken bring up the presentation, share his screen, and just let him know to advance the slide. Right. Ken, are you okay with that?
Yeah, let me give it a shot on my side.
Okay. Yeah, this internet, I've had trouble with it all morning long, and believe me, Kyle, you have a pretty face, but that frozen face.
Now I know you're lying. Okay, Ken's screen appears to be coming up here. Yes.
Which one do you have? Do you have the main presentation or the presenter view?
Now it's presenter view right now.
All right. Try to change that.
Well, it was the full screen, if that's what you were asking, and now it just switched back to.
Is it full screen right now?
It's your PowerPoint screen.
There we go. Now it's full screen for me.
All right, good.
All right. All right, so my name is Rob Sommerfeld. I work for Geophysical Survey Systems, and thank you, Kyle, and everyone involved in this for allowing the vendors to present their updates and things. Some very good information, and so let's continue. Ken, slide number 2, please. Okay. So I'm going to have to, my screen is running a little slow, so I'm going to have to just kind of do mine. So a little bit of agenda, a little bit of history features. I didn't want to take up a whole lot of time with some of this part here, saying I got 20 minutes, but calibration using cores and pucks, or the gyratory pucks, as we call them, and some of the things that we've been working on for the last year or so. And next screen, please. So the history on how it started with the DOT, way back the history, Sharp 1, and then a lot of research and R&D and things with TTI, MnDOT, and many, many others, especially some of the newer ones have come on board in the last 5 years or so. New York DOT, North Dakota has been very helpful. Maine, Nebraska, Maryland, and Florida, a lot of people have been very helpful. So the Sharp 2 initiative is where we are now, and moving forward with this. Next slide, please. So it's a continuous, what is PaveScan? It is a continuous full coverage system, in that, being on a cart or whatever type of mobile device you use to collect data, but it will do the full coverage as 3D radar and the Earth Science System showed. It does provide on-site dielectric values of newly laid and compacted asphalt, as everyone has talked about. And we do provide with real-time on-site a 2D contour map that shows uniformity when displaying dielectric values, and we also provide coring locations. But what we do is that we, through calibrations, whether it's with cores or pucks, which we'll explain later, that we allow on-site display of density information, whether you choose density, percent compaction, or percent void content, whatever the user chooses to display. So we could do that in real time on-site and have that conversion done. Next slide, please. So again, sticking with this, it can be a QC tool. I've been on many sites, Texas and a few others, where we've rolled this thing behind a finish roller, in front of a finish roller, up the road, side to side, and have discovered, for example, any patterns of roller issues. If there was a paver issue, like there was a certain section that was not meeting density requirements, number of trucks issue, all kinds of things. So a lot of decisions can be made on site if there are any issues taking place while collecting the data during the job site. QA tool, we got Pw reports, Google Earth type of reports. And some of the things was a forensic tool. For example, if there are sections that need to be ripped up, well, it may not have to be an entire section, and we can find the border or the area in which a section may not have met a specification, so that a smaller area, for example, can be ripped up and not an entire section. Next slide, please. Some of the features we've had some of these things. We do have the folding arms. No tools really required as far as assembly and mobilizing this to a job site. The arms fold up fairly easily and well. The sensors can attach and detach very easily. No tools requirement. Hot swappable batteries or something. And another thing that we have is that green laser, the lower right hand picture, from each sensor, so that it provides two different things, in that it could aid in location accuracy, like if you want to get the dielectric or density of a core area and put it in time mode and get the and have that laser at that precise location. I think that was one of the things for the green laser. And the other thing is for guidance when collecting data. You can put a green laser down 6 inches from a joint, for example, and walk along and kind of eyeball it and use it as a guide. Next one, please. This is what we do provide on site. And Ken, if you can just press a button and it will kind of draw itself out. As you go across, and if there are areas of lower density means there are more air voids, and more air being the dielectric of 1. The dielectric of the asphalt will certainly be lower than other areas. So on site, while you're collecting data, this is the actual screen that gets populated on your tablet, and it shows areas of low compaction. For example, the blue area. If you had dielectric, you could see that the uniformity of the area, that it was lower compaction. And in this case, we've done a calibration, and so the scale on the right is in density percentage. And you can see that some of that blue area was below 90%, and then you have the green areas which were around 95%. So you're able to get that information on site if you have done a calibration. And a couple of ways of collecting data. We do have a 3-channel system, in which depending on the state and DOTs that I've gone to, they do a 2-pass system, and some have done 3 or 4-pass systems. And I mean, they've really done a lot of data collection, where you go up one side of a lane and come back down the other side of the lane and basically get near full coverage as far as side to side type of data. And or like in Georgia, they do or they have done, I don't know if they've changed, but they do a 1-pass system where they basically go down the middle of the lane and collect data from that. Next slide, please. So one of the ways we do things, whether it's from the test strip or when they're on a job site, you can collect data, and it's day 1 of the job site. And when you collect data, you get dielectric information, and then we either provide the core locations, or you can do some coring, and we get the dielectric of those locations. And then at that time, cores are pulled after dielectric is collected of each location. And the cores are taken back, getting density information, and then that information is entered as a calibration file. Our system allows to save multiple mixes. so that you give that calibration a mix name in our system. And therefore, if you use the same mix later, you can pass by this calibration and just pick that mix, that calibration, and we'll automatically show density information from there. So we'll save multiple mixes for you. And also when you do collect data afterwards, we do back calculate so that when you export the data, you'll get your density information using cores. Next slide, please. So you input this information. We've gotten many, a lot of data points. I mean, we've done this for how many years now, and we get a pretty good R-squared number continuously. I know when I go on site, they're usually like 0.95. The trend line is high, 0.95 or higher. One time I got 0.88 and I was disappointed, but that's still pretty good. But we usually get very good correlation between density and our dielectric that we get on site with the cores. Those are just some screenshots on the middle and the right of the type of information that you enter into our system. Next slide, please. And again, just showing some R-squared. I use Excel. Most people do, or a lot of people do, but we do calculate that automatically for you, the formula and the trend line, and on our system. So all you have to do is put in the dielectric and the density numbers, and we'll do all the calculations for you. I'm an Excel freak, so I like to do them in Excel as well. And the other way we do is calibration using gyratory pucks or biscuits or pills or whatever state I'm in, and whatever they decide to term it. But so we use these pucks that we get directly from the plant and at certain different densities. And what we do is we get the dielectric of each of the pucks. And again, there's a known density to those. And by that, we can actually calibrate the system prior to any job site so that you can have real-time density information from day one. And again, same thing with cores. We save the mixes. So if you have several different mixes, you can save each calibration with the name of the mix. And then in future, you can just pull up the mix and connect that to each project. There's an example of what we do to get the dielectric of each of the pucks. Is a 4-step system. It's pretty easy. And again, we do save that information so that automatically gets transferred into the PaveScan system. And again, this is just a screenshot example of the results when we put it in, and you have the different pucks that we entered with the dielectric and the density numbers. I'm sorry, I forgot. Ken, can you tell me what slide you're on right now? My bad.
Looks like you were on slide 13.
Okay, so yeah, the pictures of each of the pucks, the 4 pictures?
That's correct.
Okay, next slide, please. That's a screenshot again of what gets collected and saved of the dielectric density, thickness of the pucks, and etc. And then again, all that information gets put into our system, and automatically we calculate the formula for you, and then you name it as a mix, and then for each project you go out there, you just connect a mix calibration to your job that you're doing out there. Next slide, please. And we've had, this is a courtesy of Ohio DOT, and it's out there on the internet, but you know, they've done a lot of comparison and with pucks and with the correlation along with other types of technologies out there, and you know, we seem to be a little bit more consistent and done again with the trend and things. So that continues to be, you know, the trend that we're going, and so done pretty well. Next slide, please. We do things that we have added again along with the pucks calibration. We're added like the system QA procedures. We want to make sure that each sensor is working properly prior to a job, and we do have about 3 methods that we've looked at, and you can do one of 3. the HDPE block, which is about a 2.35 dielectric, so you can just test each sensor out, plus or minus, well, 0.05, I'm sorry, 0.05, and to make certain that each sensor is working properly. A lot of times we do that before the job site and then after the job or at the end of the day, just to make certain of that. The type of data we collect, we collect sensor temperature, all kinds of things in our CSV file, so that and including noise factors and anything going wrong, we can tell what may be occurring if the data doesn't match what's out there. So there's a lot of data we collect, including this, the HDPE stuff. We do a swerve method that was come up with Minnesota DOT. And you just take about a 250-foot line up a lane, preferably on this job site, so you can kind of get an idea of what the dielectric or density is like, and do about a 2-cycle swerve and then come back to 250 feet, making it a total about 500 feet. And each sensor should not be, or the outside sensor should be within no closer than 1 foot of the joint lines. And you do that, and the sensors actually come out pretty good. I have to admit, I was skeptical, and I've done this a few times and went, wow, this works really well. Great job, Kyle. And then there's the line method, where you make a line maybe about 10 feet or so to me, again, at the job site, and you push each sensor right over that line. And again, you should have about the same dielectric with all 3 sensors. So we do a QA procedure just to see how well the sensors are working. Next slide, please. Export, we have this export range. Of course, you collect tons of data and tons of data files, you know, whether they're sections or a number of stations, etc. And again, left side, right side of the lane, and on and on and on. So what we have now is an export range where you can combine different files in different filtering ways, all kinds of different ways. I want these files put together, I want these, or I want all of them put together, and export the entire data file, your entire job, if you wanted to, in one file, one export file. And those exports do include a .csv file, which has tons of information, as well as a .kml file for Google Earth purposes. And again, whether you use dielectric only, that's what gets exported. But if you have done a calibration, you can get density information with that, so that you can display or graph or whatever you want density information. Lane extents, what we've done now for the PWL, we do percent within limits reports now, in that we allow the user to define, you know, where the joint is, like how far the asphalt should be within the joints, and then what's the main mat, the mat area, and so that, and whether the joints were confined or anything like this. So you can define the area where the joint mat is, as well as the regular mat, and then produce different reports for PWL reports. And these are examples of a PWL report that you can do with the lane extents and the information the user puts in to define the lanes within the lane, define the sections within the lane, and produce these type of reports that you can see on the right. And again, I'm sorry, Ken, what's on the screen? I keep forgetting next screen.
You're on 19.
19. Yep, these are the PWL reports. Thank you, Ken, for keeping up with me. Next one, slide 20, please. And again, these are examples of CSV file. Sorry, it's a little small, but just to give you an example of all the PWL reports. And then from these type of reports, the percentages that were within the specs and et cetera that the user gets to define. And then, of course, you can decide what to do with those type of numbers here with the PWL reports. Next slide, 21, please. And linear and area defects. One of the things I think is, believe it or not, an easy thing, but a big deal. That's a lot of data. We're collecting a heck of a lot of data, including the range reports, range outputs and things. So that's a lot of data to scroll through. I put a lot of things in Excel, and I usually, you know, I have to set up filters. I usually have to copy and paste the data over to another sheet and all kinds of different things. So what we've come up with is allow the user to input information on what is defined as a defect. things that are out of range, or I mean, not out of range, but out of specifications, and allow the user to do that so that when we export data, another part that we export is for linear, that if you know, the specs weren't made for a certain distance, a minimum of a certain distance that the user inputs, it will output that information, and just that information. Area defects like 100-foot square area or whatever it might be, or whatever the user defines, again, an area of a defect. So that, you know, minimum, you know, we don't want to, you know, a 1 foot by 1 foot area that's a defect. Will allow the user to define what the area is, square footage wise, what is considered an area of defect. So you put that information in and you do export data. And next slide, please. And you get information of just defects. And you get a KML file on the right, and I think you can see it okay, is the little red areas where the defects were. And again, that helps you define immediately exactly where, you know, you know, rollers or whatever, or the paver stopped, or all that type of information. So defects only, so that allows you to not have to go through all this data. I mean, you have all this data, which is great because it's great baseline data for future projects and for future of the road when you check it out again 5 years later to see what the data showed 5 years ago as opposed to what the data is showing now. So you have good baseline data as well as this now. Next slide, please. Deployment options. So we are creating and develop some ways. We've been actually doing all of these things, different ways to deploy this thing. Vehicle, whether it's a van or golf cart. I believe Georgia DOT has put theirs on the golf cart. Minnesota's done tons of different things. Just yeah, amazing. Segway, we played with the Segway, and actually we have a mounting system. You would get your own Segway. But we have a little mounting system that lets you attach a Segway to the back of the cart and kind of zoom along. That's a lot of walking that you do out there. So we've actually collected data on site. Ken is enjoying this Segway quite a bit, and he's doing a great job collecting data. I'll show you some data. And we've done this robot here on the right that you know, you put in some GPS coordinates or you control it. And let the robot go, and you're out there watching that thing go back and forth. And we've actually been able to collect more data by you know, just going back and forth with smaller type of things, smaller that.
You got about 2 minutes, Rob.
Okay, well, next slide, and that's all I'll need. So with these deployment options, you can see there we've collected a lot more data. Ken, I can't remember if you collected with the Segway or was this a robot data? I don't recall off the top of my head.
This is Segway.
Segway. I was like, Ken has too much fun with the Segway, but this is a lot of data that we were able to collect in a short period of time. And you can see this is Route 3 in New Hampshire, I believe, which was one. Next slide, please. And again, with Google Earth, you know, you can really get out a lot of information, and contractors write some amazing notes out there about where, you know, the paver stopped, or what, you know, what may have occurred during that time and things. And of course, on the right side, it's bridge data, which is always lower density, or most of the time. I believe Richard Giesel's doing something to improve that, but he's using the PaveScan to help that information. Next slide. And this is, like you said, Google Earth that we can produce using the range output. And again, the contractor really does take some good notes about what happened, roller sat there, or all kinds of different things that may have occurred during the job site. Next slide. And of course, we do output the Veda. We output PWL files, KML files, and then we could also see IR, where, you know, you see a small strip at the bottom where it was cooler, and where, you know, where the PaveScan system showed that it was lower density in that little area there. And last slide, 2 minutes is up. So thank you very much. Again, thank you, Kyle. Thank you, Ken. And I appreciate it. I'm glad this worked out very well.
Very good. Thank you for showing your teamwork, GSSI, and the teamwork of passing the baton on the presentation slides and all that. So, and of course, great work with what you've been doing with the technology. So thanks for sharing. We do have some flexibility in our schedule. We have the last half hour is just designated for discussion. So I think we will try to make it through all the questions, at least that have been coming through the chat. And I think I'll just start at the top. And in this case, I would open all of the questions to all of the vendors if they have anything to say about it. So the first question we had from Irv, I'm glad we have Irv with us. He's got a ton of experience, clearly. So Irv was asking Jacopo, how long after paving were the measurements made on the new pavement that you were showing?
Yes, I tried to search for that information in the meanwhile, since I haven't collected those data myself. I can certainly find it, but I believe it was some months without being extremely precise about that. But it was not immediately after the, while it was laid down or something like that.
Okay, and not to continue on the questions about the data collection itself, which you've already said you weren't part of, but do you recollect getting any feedback on if you were able to deploy the method on fresh pavement, or is the means of data collection conducive to being able to go on a freshly placed pavement after the final roller, or hard to say at this point?
A bit hard to say, perhaps not with the vehicle, I guess just for practicality, but I think a solution can be found in general.
Yep.
Yeah.
Very good. Very good.
The system itself is very lightweight, so it's not, the array, although it's wide, is not really heavy. So.
Okay, good. Thank you. Dr. Shangtao Dai also asked, do you have a way to check/measure consistency among antenna pairs in the array? And this was a question during Jacopo's presentation, so I'll let you go first.
Yeah, so the answer is yes, there are different ways, but I'll tell you that I think the easiest way is, we have such a dense data set coming out of the system that if a pair is slightly out of the others, you will see it immediately. It makes a very marked stripe, even if it is a tiny variation of let's say point up to 0.1, between 0.05 and 0.1 in dielectric, and is a constant offset, you would really see it, because it's like a punch in the face. It's like a cut through the Mona Lisa.
Yeah. Very good.
Can I add something here?
Yep.
Okay. Thank you, Jacob. I thought it was great to see you made a good improvement in 3D radar. I guess my question is, if we try to use the radar to capture material variation, the density variation and the field, but we just want to see or check or minimize the variation of the antenna itself. So between pair 1, pair 2, pair 3. So before we go on the field, is there any way we can look at the difference between these antenna pairs?
Yeah, well, a static scan would be enough, and we do have this is related also to other discussions we are having, for example, with Caltrans, with below one there. And he would like to have something similar, so that also he can include it in the report. The system was checked and something like that. So it's a bit of an ongoing discussion, but I think, as part of the routine, passing on top of a known material, for example, while driving the van out, that is basically enough. You want to have something that is a repeatable measurement and the way to measure it. So a repeatable thing to measure and the way to display it. And we have ways to display the distance between the channels in frequency or time domain. Frequency domain tends a little bit more explicative. It's just one value, for example. And or you can summarize the information better. That's probably better to put it that way. And it's very similar to tools that we use during production. When we put an array out in the world, we have very strict procedures to measure that the channels have a very similar response, because that really affects the image. We can have very tiny variations are are very visible when you have a densely populated array systems.
Very
Thank
good.
you.
Yeah, and I know the other vendors also touched on sensor consistency in their presentations. Was there anything either Chuck or anybody from GSSI would like to add from a sensor consistency point of view?
I'll go ahead and start. This is Rob Sommerfeld, GSSI again. As you saw, we have a couple, well, 3 ways that for sensor consistency to make certain that they're working properly. I showed the HDPE type of method, the swerve method, and then the line method. We check closely to see it to make certain that they pretty much match each other. We certainly would love to match each other, but we have a very strict the error as far as not being greater than 0.05. I've seen it, smaller than that. But it's worked out pretty well. But I'll tell you, Kyle, that swerve method is amazing.
Yeah. So and we've had success with using either swerve or line test. So both of those two. One thing I'll just say about that, again, the purpose of this is for the vendors to talk, is that the HDPE method, at least in our experience so far, didn't necessarily translate to bias that we were seeing in the asphalt if it's present. So Chuck Oden, do you have anything to add on sensor consistency?
Not really. We've only used the HDPE method, so we definitely need to look into the swerve and the line method. But I will say, as far as the HDPE method, I think the AASHTO, I think 0.05 has been tossed out. Correct me if I'm wrong. I think the AASHTO spec is 0.04, if I'm not mistaken. But that's just a small difference.
Yeah, there's a series of tests in the AASHTO equipment spec, and most of them are set at about 0.08 in terms of meeting the performance. But there's long-term, short-term stability and
right.
Like
so it's 0.08, and so you could say plus or minus 0.04. That's kind of the way we look at it.
Okay.
But no.
Yeah, gotcha.
But I must say, we definitely should look into the swerve and the line tests. We've convinced ourselves that the HDPE test was good enough, but I'd like to hear more about why it's not.
Okay. And I think we'll continue to move on to make sure we get all the questions, but maybe as part of the discussion, we can go into more details on sensor consistency. So Leslie Myers had a question for Jacopo. Can you define noisy?
Oh, yes. By noise, maybe it's a little bit one size fits all. What I was trying to say, also due to time, we could talk one afternoon about what is noise and electromagnetic interference at different levels. But in general, it means, in our case at least, we have a frequency domain system. So to create a time domain version of it, we need to sum up these frequencies. I'm making a long story a little bit short. But imagine that you have all these components, right? All these samples, and you're summing them up. A noisy environment is one in which some of these samples, then you can have more noise or less noise, but some of these guys are not consistent with the others. So they are biased by another signal coming in and affecting a very narrow band in your data set, in your trace. So that would be a noisy environment, right? So it means that these frequencies are not carrying in any information that can help you, in this case, determine the dielectric constant, and they do not participate in the information that would finally bring you an amplitude that can be transformed into dielectric value. Now, there are different ways to tackle this. I'd be happy to discuss them maybe in another. Not necessarily today, but imagine that if you have two choices, basically. Either you suppress this sample, which is not really informative for you, or you interpolate it, or you simply don't disregard it. But you need to do the same, for example, in the reference data that you have, the ones that represent 100% reflectivity. Otherwise, you are anyway biasing the result by weighing in a sample that you do not have. So it's a little bit of a chain of consequences here, but finally it leads to smart choices that can be taken during a, on an algorithmic point of view.
Very good. Thank you, Jacopo. Did Leslie's
Thank
giving
you.
the thumbs up? Okay.
Yeah,
thank you for the question.
Thank you.
All right. The next question from Dale Peabody, and actually Leslie seconded this one, is are any of the systems able to accurately measure dielectric in thinner HMA lifts, say 1 inch? And I'll open that to, I think that was it was during Chuck's presentation that the question was asked, but I think that's applicable to any of the vendors who want to speak up.
Do you want to give it an order? First.
let's go Chuck first here.
Oh, okay. Well, the actual depth of penetration depends on the dielectric constant. And when we said 1.5 inches and 3 inches, which are two depths of measurement, I think that's for a dielectric constant of 5. I would have to go back and check. In the case where maybe you have some lime aggregate and the dielectric constants might be closer to 6, then I would say potentially, we would be pretty accurate at 1 inch. The way we determined those depths of investigation was by, sort of buried metal plates. And so when we say 1.5 inches, most of the sensitive region is above that. So I would say that we do, we would approach 1 inch, but I wouldn't stand behind that absolutely. I don't know how else to answer that.
Yep, very good. Anybody from GSSI want to comment on effect on thin lifts?
Sure, I'll jump in. This is Dave Sist. I agree with Chuck. I think we can do about 1.5 inches. And if you wanted to do 1 inch lifts, I think you would be mostly accurate. But if you put a metal plate under a 1 inch lift, you'd see it. So I think the risk is very low, frankly, of having an error with a 1 inch lift, but we would not stand behind it. The second thing to say is we wouldn't be doing our job in research if we weren't working on that as well. So we plan on aiming at thinner lifts as well.
Thank you very much, Dave. Jacopo, anything to add?
Yeah, one thing that I would bring into the discussion, that's because, we have this a bit of a different system. So we have three-dimensional point of view, is that there is one thing that I would advise everybody to be a little bit careful in general when you're talking about thin layers, is that you need also to account for the fact it's not only the depth, it's also the granularity. So at that point you arrive at a certain moment where basically the granularity of your layer, and if you see in the images that I've shown, you can see the grain, right, of the asphalt. That's what you're seeing. You're seeing an image of the surface and of how the asphalt is. You get a feeling for the texture, all right? Sometimes it's a little bit more, sometimes a little bit less. So what happens is that you're getting some micro scattering, and what I think that might happen at a certain point, if we go very high up in frequency with an impulse system, which means, you have a thinner pulse, but also you have a higher central frequency. In our case would be, adding samples on the high end of the spectrum and more than on the low end. But what happens is that finally you get a little bit more micro scattering that might affect your amplitude as compared to a very homogeneous layer, right? And since the asphalt is a granular layer and has a certain composition, and actually that's the thing that we are trying to exploit here, I'm thinking that you might go and extrapolate. You might go in between, an amplitude that is meaningful in terms of the dielectric constant, and an amplitude that is meaningful in terms of scattering from very tiny objects, which are the stones in the asphalt. So that's where I think the limit of the technology will be. To tell you where exactly it is, I wouldn't know. But for sure, when you started to say very thin, that's also another thing to consider.
Great. Yeah, and that was some great answers by the vendors, and that's the purpose of this meeting. I would just quickly add that we're also looking at that as part of the pooled fund, and NCAT is doing some studies, and it turns out you can kind of, as Dave was alluding to, measure at less than that 1.5 inch level, but it's dependent on what is underneath. So if there's asphalt on top of Portland cement concrete, that's a much different problem than asphalt on top of another lift of asphalt with a similar dielectric is what the initial findings seem to be showing. So great question, Dale, thank you. Amanda from Transtech added, I think this came up during Chuck's presentation, that Veda does support linear calibration data. So that's nice to know. Thank you, Amanda. Di asked Chuck, I believe, can you elaborate on how to use the Bachelor model to develop dielectric to density relationship?
Sure. So really with the Bachelor model, we assume a certain a certain binder fraction and a certain binder dielectric constant. And the calibration is really just adjusting the aggregate dielectric. And so it's a single variable. And you know, that actually works quite well because you know, even the binder has such a, you know, 6%, 7%, whatever it is. The dielectric could change by 10, 20% and not affect things very much. And so using it as a basis model to fit our response curve is really what we're doing with it. And as I said, you know, it's effectively a linear calibration anyway. So to define that line, if we have one point, we've got enough information to effectively solve for what we need to use in the Bachelor model, I guess.
Very good. Dale had a question that got a thumbs up from Jeff Brunner. Would like to be able to share dielectric or density map in near real time with project personnel. Phone app? ? And I think that was during the GSSI presentation. So does anybody from GSSI want to comment on the question about the possibility of a phone app?
Sure, I'll take that. This is David Sist again. It's something we get asked all the time, and in fact, it's something you can do now using the Google Earth phone app, and you can simply transfer the Google Earth map to the phone and send that around any way you want. That is probably only half an answer, but I think a phone app is a great idea, and we're certainly looking into it.
Great. Any other vendors want to comment on the phone app idea?
I'll comment very quickly. You know, our reports can be sent to phones, and so we generate a KMZ for Google Earths. We generate a Google Maps file that you can send to anybody, and it'll pop open in a web browser using Google Maps. So as far as sharing the information, and we can produce a density map in real time. So as far as sharing that, we can certainly do that, but it's sharing the results of the survey as opposed to a bona fide phone app. We don't have a bona fide phone app.
Great. And then Dale, did that answer your question, or would you like to expand on that at all?
Yeah, I think it answers the question, you know, and we've talked about this in the past, you know, the being able to share that information quickly to others so that decisions can be made. You know, having the data is great, but if you're not able to share it immediately and have the contractor make decisions or changes to operations, it's kind of lose a lot of the value of it. So yeah, I think we're good. We're good there. Thanks for the
nice question. And if you haven't noticed, we're already into the discussion portion, so I'm still going to work my way through the questions specific to the presentations, but please feel free to ask your questions in the chat, and it could be whatever you'd like. And just to follow up on what Dale was saying, that's kind of the purpose of these sorts of meetings, to be able to give this feedback to the vendors if they are to come up with a phone app, you know, to be able to ask us and figure out, okay, if we prioritize, what are we putting on that screen? What are the things that we'd like to see? And they can obviously compare that with what's possible or not. But a great question, and I think a good use of this type of a medium. So thanks for that, Dale. Brian Nagel said, is there anything being done from any of the vendors to try to quantify moisture during measurement? And I'd open that up for any of the three vendors who want to speak first.
I'll start here with just a quick comment. We're not quantifying moisture. We obviously understand the problem and understand the seriousness of the problem. And I guess as we move forward to try to put forth a standard, I would suggest that we look at what the non-nuclear gauge vendors went through in trying to tackle the same problem.
And then maybe I'll answer again. This is David Sist at GSSI. Is anything being done? Well, yeah, we're doing research all the time on this one. This is a big deal and it's sort of the Achilles heel of the whole DPS system, since radar is really, really good at measuring moisture. So we are doing everything we can to account for it, but we don't have anything to present at this point.
Thank you, Dave.
Yeah, and I would add the same comment basically.
Very
it's
good.
And it's been really observed. In our case, for example, it's enough to be taking the measurement 10 minutes away when it's early morning or something like that. You see a change.
Very good. Yes, and thank you to all the vendors. One just general comment. You all are very good at presenting your technology in the best light possible without overselling what it can and can't do, and I think that goes a long way towards trust and building this technology together. So thank you for that.
Yeah, mine can do coffee. Yeah.
You can do espresso with yours. The next question is from Dennis Dvorak. What is the maximum speed that each system can collect accurate data?
Well, maybe I can start just because mine does coffee, so I can tell you also that it goes fast. Well, no, apart from the, I would say that the datum, I said something like 45 miles per hour. That's where we see that it goes, that we get still good results. I wouldn't go crazy fast, so mostly because of if you have too many shakes or something like that, there's other stuff that can go generally speaking wrong. So it's but a good mount is the key here. So we've seen our customers basically solving the issue of speed by having a good mount.
So in your experience, the actual physical movement of the antenna is a major factor for how accurate your high-speed data is.
Well, it was definitely something that we had to take deeply into consideration while we were designing the algorithm. So, let's say a simplistic approach, which was what I presented back in the days, let's say that what we were doing during 2019, it was working okay, but also very much not okay when you were introducing bouncing. So, one size fits all didn't simply work. So we had to do it better, to have a more complicated model and a better model. So to be more careful in creating the models and basing algorithms on something solid, and then test. So we've done a lot of shake tests in a way, or bounce tests more than shake tests, making sure that everything was accounted for, seeing what was the result of adding a mount, adding different kinds of mount, what happens if you shake in a way, shake in another way. And I think we ended up with something very solid. In fact, the data that I presented today were all collected at dropping speed, apart from perhaps the latest one, the repeatability tests. They were collected as probably around 20-25 miles an hour. So still fairly fast, if you want.
Very good. And I think I saw Dave's, you were lighting up there, like you were ready to say something there, Dave.
I was, but I'm going to give it to Roger.
Okay.
This is Roger.
Hi, Roger.
We're looking at about 20 miles an hour for vehicle mode. So that's the fastest we can do.
Very good. And Chuck,
And I'll just
anything to add?
yeah, just very quickly. We've only done tests. We've designed the system for walking speeds, and as we go faster, you know, with the vehicle, we're pulling it with a vehicle. We've pulled it at walking speeds, and we can certainly go faster, but the issues that we run into really are more vibrations with the cart. So if you run over a pebble or something like that, that's kind of what limits us. So you know, we're gonna stay at walking speed for now, and we're gonna do more testing to see if we can go much faster.
Very good. Thank you very much, Chuck.
Kyle, one
Yes,
sec.
go ahead. Yep.
I totally forgot. We had it on the van, and time mode with GPS. Pretty much you can go 60 miles an hour and really obtain a very nice KML plot. So the distance between scans is more than a foot, but you can definitely go highway speed.
Okay. Very good. So if you have a high accuracy GPS, an option to go highway speed is available with the GSSI system, sounds like.
Yes.
All right. So let's move on to this looks like the first question that's more from vendor side to the agency, basically asking from an agency perspective, how do you deal with one or more small bad spots if a majority of the pavement is in good condition? I would say that's more of a Kurt Turgeon or a Dale Peabody type question, if you guys are willing to speak up, or anybody else, of course.
Well, I mean, we have, for the thermal, we have calculations that are done geospatially. We look for patterns. Paving is a linear thing, and you end up with linear streaks a lot of time when you're looking at segregation. So we have calculations that, you know, every 150 feet we calculate what happened in that 150 feet, left, right. So it's not a question of a bad spot as much as that lot of paving was uniform or it wasn't uniform. And we may get to that point with this as well, that you know, there's different ways to go with this. I think, like as I said at the beginning, we need to put this out there in a way that the contractors are readily using it, and then the spec writers are going to get their arms around what we can and can't do with in terms of what's acceptable. Do we have a percent within limits on the longitudinal joint? Do we do geospatial things? Are we sampling the whole pavement from one end to the other, or can we just sample you know, random 150-foot segments? You know, those are all in spec development. But right now, we still got to get this deployment figured out. Is, you know, is it a cart? Is it a robot? Is it on a golf cart? And is it something you can put in the hands of what unfortunately will most likely be the low man on the totem pole on the paving crew, because they want the smart people running their hundreds of thousands of dollars worth of equipment. And what we've seen is if they can get a reasonably smart kid who's home for college from the summer, that's who gets strapped to the cart. And unfortunately, those kids go to school in the fall. So when we're paving this time of year, we get even lesser interested individuals. So
They're good with technology, though.
So yes, some of them are. So I think, you know, when you start asking how is the spec going to work, let's get the thing actually working day to day on a large number of projects, and the people who write specs can start to answer some of those questions.
Yeah, great stuff, Kurt. Craig Landfeld, I know you have something to say about this.
Well, I was just going to say, I mean, I agree with what Kurt's saying there, but I think one of the things that I had to tell some of our folks, and we're going to have to get past, is, you know, this idea of perfection. And when you start measuring this much data and you basically capture the entire population, you're going to have to accept that there will be areas that are on those tails, and you know, you're going to have areas that don't meet your standards, and you know, at least what you would like to see the density be everywhere. It exists today, and it's going to exist when we have this. You're just going to know about it more readily today when you start scanning the entire mat area. So you just got to kind of wrap your head around that there's definitely going to be areas like that, and we're going to have to write specs that are fair and, you know, challenge contractors, but yet are fair. That's my 2 cents.
Very nice.
Just to add, this is Dale from Maine.
Yep.
You know, we haven't used the technology yet to make the contractor go back and repair or remove any bad spots. So we haven't gotten to this point. So we can't really answer the question with the new technology. And, you know, we have removed and will continue to remove material that visually is defective. And, you know, I think we do that every year a little bit, sometimes some years more. So I suspect there'd be something similar with the technology as well. And Kurt, did I hear you right? You're actually paving in mid-November in Minnesota?
You know, I'm not sure that we're paving today, but we usually have an asphalt conference the first week in December, and then I go contractor to contractor and ask them, well, are you running? And invariably, at least one plant will run right up to Thanksgiving. So.
Well, there you have it. A lot of great stuff there on that conversation. We'll move on to Kevin Clethermus. Does any do any of the vendors have a system warning if the system is having problems? For example, if the radars are failing, including power sources. So I'll open that up to any of the vendors.
This is Roger from GSSI. We have a number of checks. The first check is done when we calibrate the antennas. It tells you if the antennas are out of height range, if they're out of position, or if there's some other problem. The second check is during data collection. We look for dielectric range. If it's out of a certain dielectric range, then a pop-up warning occurs, or if it's out of height range. And we log all this system information so the user can access it afterwards. So there are a number of checks, including antenna disconnects. So if an antenna stops working, there's a pop-up message. So quite a few checks.
Very good, thank you. Any other vendors want to talk about system warning or system failure?
This is Chuck with ESS. We also have a lot of checks. You know, as far as line calibrations, the software won't let you record a line if you haven't done your line calibration. You know, in terms of temperature and battery, temperature stability, you know, there are indications on the screen if for some reason the temperature stability is not good enough. So there are indications for some of these things, but we could certainly add more as well. But yeah, we're trying to keep people from collecting bad data as best we can.
Very good. Jacopo, anything to add?
Yeah, and we do also have a set of warnings. We have a power warning, apart from the fact that you can actually open what is called a system monitor tab or a window within the client software for data collection, and you would get a lot of variables like temperature in the array, temperature in the gyroscope, which is the radar, the center of the brain of the radar unit. And you get also connectivity warnings. You get a warning if the internal or the external GPS. We actually have an internal GPS module and an external one that is whatever GPS you have. You get an audible warning if one of these loses a fix or gets disconnected. You get certainly a warning if the antenna gets disconnected, apart from the fact that you would stop seeing data coming through. You get yes, various types of warning depending on things that might be wrong. For example, if you experience a failure and the signal is not the way it should be, which ultimately in this sense means, please remember, we don't have, the system is not only to correct the electric values, right? So in general, it gives you a warning if the signal of some of the channels is failing, and that is directly related then to your amplitude readings and therefore the dielectric values that you would process. So
Very nice.
the answer is yes also, and that is also logged as well. Very sensible thing to log everything so that at least we can then you can inform back the manufacturer. You can send us the log and we can provide some troubleshooting.
Very nice. I saw that Glenn said he had to go, but he said follow the money before that. You don't happen to still be on to expand on your follow the money comment, do you, Glenn? Okay, he must have had to take off. I'm assuming he brought that up when we were talking about defects and the negative effect that can have if we focus on penalizing based on just on defects. And officially everyone is dismissed, but I'm going to stay on because I'm interested in the questions. And if you want to stay on too, I would like to continue with this discussion, but if anybody needs to go somewhere, we won't hold it against you if you have to leave. So with that, let's go to Neil Fannin says for the PAVE-IR person. For the PAVE-IR person, has anyone ever suggested using GPS to track paving speed to incentivize and disincentivize good basic paving practices?
I'm assuming I'm the PAVE-IR person.
I think you are.
I mean, the PAVE-IR system does give you paver speed, but you know, that's getting into a little bit too much hand holding for the contractor. They've got to figure out, you know, I will tell you that one of the things we saw right away was these pavers were sitting still an awful large part of the day. And I think that's one thing we've definitely seen change. The contractors figured out how long their pavers were sitting still and they realized they were losing money. So we don't see them sitting still for long stretches of time. Not to say they don't stop occasionally, but now we've got some people now who they start their paver in the morning and it doesn't stop moving till the end of the day. And more that's the case. And how fast they're going. That's the other thing we managed to do with the intelligent compaction is we had people whose pavers were going, you know, like a bat out of hell and they only had 3 rollers. And we were very easily looked at the IC data and said, well, your paver's moving so fast, your breakdown roller is barely touching the mat. It's just racing to keep up, and you've got areas where your breakdown roller doesn't even hit it. And we gave them choices of stop or slow down or get another roller, and we had all the information and they couldn't argue. So, you know, more information's better.
Very good. Rick Bradbury, you have your hand up.
Yeah, just to the question about the PAVE-IR, I think rather than incentivizing or disincentivizing the paver speed, I think they're on track. The PAVE-IR is a great, it's like having a full-time inspector who, you know, never leaves the job and monitors everything you want them to monitor, but you incentivize or disincentivize actually what you're looking for, which is smoothness. We measure smoothness and we have pay adjustments for smoothness. A smart contractor will use the PAVE-IR data as far as paver speed, paver stops, inconsistent temperature to get the smoothness. We had a project with huge disincentives and 2 lots that were in reject, and it turns out the paver stopped for more than a minute 23 times on average per mile of paving. As Kurt said, they're stopped all the time, which leads to poor smoothness, which leads to large disincentives.
Good stuff. Robert Hinman, anything to add?
Yeah, I was going to say something very similar about showing the end result. When we collected a bunch of IR data, we could sit down with the contractor, show them the impact of all that stopping and show them in terms of density and in terms of roughness. And it's amazing how well those correlated with the paver stops. And you could just overlay the data and show them exactly where they were going, and just then have a conversation about their operations too. I mean, is that really an efficient use of operations if you're speeding up and, you know, going like gangbusters and stopping? I mean, you're from even fuel consumption from your equipment, right? Is that really what you want to be doing? And sometimes the workers like it just because then they get a break. But, you know, if you show them the end result, what that means to the company itself, I think that goes a long ways.
Very good. Yeah, and just to tie it in with the DPS data, that's actually one of the first things we noticed when we gave the data to Kurt early on before, you know, we could get it officially into Veda. There was a lower spot where it just all of a sudden one side of the lane was completely lower density than the other, and the paver was just flying down the road on the low density spot. So they just weren't keeping up with their rollers. So ideally, you're just measuring the result. If they're able to keep up at that paving speed, more power to them. But when you have technology like DPS and some of this other stuff, ideally you're just measuring the result. So
well, I think it can be helpful too in having a conversation. Look, you can optimize your operations better too, right? Yep. I mean, do you have too many trucks going out? Are not enough? I mean, so it enhances that communication among them so that they could be more profitable. And at the end of the day, that's what they're looking to do.
Mm-hmm. Great stuff. So Todd Mansell said, great point, Craig, which Craig always makes great points. So you were safe with that comment, Todd. The DPS sensors on the paver directly behind. That's a question for the vendors.
Maybe I'll take that one to start with. It's Dave Sist again, although I moved rooms. Yeah, I've been surprised how many contractors I've asked. I've asked almost every contractor about this question, and I've been surprised I haven't had one interesting nibble on this one. So we've been surprised at the lack of interest in this one. Kurt, if you want to email me later, I'm happy to chat about that. But it's not been something that's lit up our answering board.
Yeah, go ahead, Kurt.
Sure. Yeah. Thanks. Yeah, I would think it would be interesting to see if you could equate it with segregation, for instance, coming out of the screed, right out behind the screed. You could see some differences in compaction that could be monitored right on the paver.
Yeah, I would think auger problems should show up nicely, but I haven't gotten any interest.
Okay, thank you.
Any other vendors want to comment on directly behind the paver?
Well, just that we have this water issue that we have to tackle. No small issue. I'm not sure that we see a path forward with that right now.
And just from a comment from a former contractor, that the other issue is how much stuff can you hang on the back of your paver? I mean, we're doing, yeah, there's a limit to how much you can attach to the paver, which I think is a problem. And then the same comment I think applies to why you haven't seen a lot of interest to attach it to rollers. Roller operators are a very unique breed, and complicating their life tends to make them testy.
I was hoping they could start and stop the robot at least though on that final roller, so we'll have to revisit that later.
Yeah.
So, are there any other comments on the mounting it directly behind the paver? A very similar comment, mounting it behind the finished roller might be best. And we saw Bryce Worry present that as a possibility last week. In that case, you have the moisture issue, and there's some things that you could. Thanks, Irv. Irv says good session. Bye. So anybody else have any comments on possibility of mounting to a finished roller? Maybe we'll start with the vendors.
I guess I could quote Ollie North. I think it's a neat idea.
Okay. Anything else to add, vendors?
But not really. Do you think this is going to be? It depends if this is a solution that wants to be adopted, or is a curiosity, you know.
Yes.
So well, it's very often you get the chicken and the egg with GPR and sensors, right? It would be nice to have, but also not. So it's if you do it, I might be interested, but if you don't do it, I might not be interested, or
Right.
we'll
I know
never
what you're
know.
saying.
The truth. Yeah.
Well, and that's actually a good point. Why maybe we should. Is Matt Ullman still on?
Yep.
Let's get your perspective, not to put you on the spot, Matt. You think from a contractor perspective, the type of data you'd get from a finish roller, we can start, and maybe we can even talk about intermediate rollers too. Do you think that would be something useful for a contractor from a QC perspective?
I could see it being useful in that sense. I think you'd want to have it so it would output from the roller to a phone app. So someone else could be sitting on the side of the road or in their office or wherever and track that data instead of the roller operator doing it, because depending on what you're looking for, unless it was very clear cut, we'll get back to the IC stuff where they're on the display, same with pay by hour, but it really depends on what we're trying to tackle with it. So, but it would be interesting. I'd certainly like to see it sometime.
And good, we have Bryce with us too. Do you have anything to add to that, Bryce?
Yeah, the only reason we kind of started dabbling with mounting that on there was the logistics. Trying to keep up with a paver moving 60 feet per minute and 4 rollers and traffic closures, and there was no way to keep up pushing a cart. And in a lot of states, you have to collect this data or take your course before moving traffic control up. So, you have to kind of do it in that closure area, and when you can't keep up to the paver, it's kind of frustrating. So, it's just kind of one of the ideas we did, and we did ran some test sections with it, and definitely the moisture is the issue, and that's why we kind of use the exhaust outflow to try to dry or blow any moisture from the finish roller out of the way. So it has to be back in the finish or correction roller position to be even used accurately a little bit. So definitely.
If I could jump in right there. Yep. That was the whole reason we thought the Segway was a good idea, because you can actually cover adequately. So it sort of saves the guy from having to walk 20 miles to do the coverage. And we are able easily to keep up with the train off the back right up to finish every time. So it really does solve that problem.
Very good. Yeah, one thing I would add, our experience, we also were able to start using the Segway. Mercedes, more specifically, was our Segway expert. And I totally agree with Dave there that it helps with keeping up, even doing the multiple passes. One thing logistically, you still have to figure out, especially for some of those moving partial closures, is we still need to do multiple passes back and forth, and the roller obviously is doing multiple passes back and forth. So timing it up so that you're starting when they're finishing, there still can be a little bit of lag there, and it looks like Bryce has something to add to that.
Yeah, and that's actually what we did in the testing. We linked it to the timestamp of the intelligent compaction, so we could actually get RTK location and match it up with the GPR data. We were getting interference from the actual roller itself, so the data we were collecting was not accurate, but just knowing that it worked, and the exhaust, it was blowing out 130 to 150 degrees air, just like a air blower onto the mat. Kind of any moisture that was on the surface was being pushed out of the way, so we were kind of controlling that water issue. There's a lot more opportunity with it. We're just kind of in the starting testing procedures of it. So, yeah,
and just to, oops, I was trying to lower Bryce's hand and I did something. I hope I didn't kick anybody off. So one thing I did want to mention is that, these discussions of can we do this, can we do that, are great, and I think that's the purpose of these kind of meetings. But we don't want to give the vendors the impression that we're just trying to move the goalposts here all the time. One thing we're committed to, at least in the pooled fund, is saying, okay, the technology as is, how can we use it and how can we try to deploy that? And if there is something that is a barrier to deployment, we just want to be able to communicate that to the vendors. So we do appreciate you guys, responding to our questions and comments, and sometimes maybe asking for difficult solutions. So we have drones. We have talk about drones here. Do you want to expand on that, Kevin, or anybody else? What do you have in mind with drones, Kevin? He might have left us.
No, it was Er's comments.
Okay, yeah.
Behind the paver.
Yeah. And then Dale Peabody, have a college student operating the finished roller. So that would kill two birds with one stone. It would make the person able to operate a robot and deal with the difficult personalities of the final roller operator. And then Bryce said contractors that use these technologies for quality control right now are the ones that have the most success in ride and density. These tools help develop consistency in the field. And that's great to hear, Bryce, because even though, in the pooled fund, we're looking to try to get it usable for density acceptance, it's awesome if that data can help with consistency in the field and building it the right way from the beginning. So thanks for that comment. And you got 2 upvotes with that too. Rick Bradbury says both PaveIR and rolling density meter can be used as a QC tools to meet the goal of R06C, reduce segregation and improve pavement smoothness and durability. And that, ties in with what Bryce is saying. So even though we're trying to get it to the point where we can deploy it as a density acceptance tool as an agency, that does not preclude it from being a great tool to help reduce segregation and do improved paving in the first place. So we're 17 minutes over, but I did let you guys know you're free to leave at any time. So we actually ended right on time. This is just the bonus VIP session. So please don't feel like you need to stay if you have something else going on. Steve Cooper, good to hear from you. Can autonomous DPS be programmed to maintain certain distance from the final roller? It's a good question. Do any of the vendors want to answer that one? I see Jacopo, you have your hand up.
Yeah, it was for something else, but
okay.
I can take this one quickly. Well, yeah, that depends on the autonomous thing you're using.
Yeah.
So in general, I would say yes, but I'll let also the other comment.
Any other vendors want to comment on having the autonomous DPS program to maintain certain distance from the final roller?
So yeah, this is David Siss again at GSSI. We've talked about this extensively with contractors, and they, some of them smirk at me when we talk about this. I say, well, if you can get, a luggage bag to follow you in an airport, why can't we do this with a roller? But they always talk about the cost of what happens when when it runs out of battery and the roller operator is not paying attention. It smooshes it like a bug. So we haven't, this hasn't been one that people have, been asking for. Let's put it that way.
Any other vendors have a comment? Well, I know they have autonomous rollers now, and I think, Steve, did you see autonomous paving even happening? Did they answer your question, Steve? Do you have any more comments?
Yeah, no, it did. It did. And you're right, Cal. I have seen certain articles where industry is pursuing that for the rollers.
Yeah, do we have any industry who's stuck with us who are aware of kind of the latest and greatest for the autonomous rollers? Or maybe they don't want to share if they do.
Hey, Kyle, this is Brian Nagel from Caterpillar. I guess in general, yeah, there's a lot happening in that space, right? Everybody's trying to reduce manpower.
Yeah.
You know, I think safety and, you know, let's be honest, a paving job site, there isn't one that's the same as the other. So that inconsistency is a big challenge. But I think a lot of the OEMs are working on the building blocks to get to that. So as you think about, you know, just intelligent compaction, what that's done for sort of measuring and documenting and putting some smarts into a machine, and then you step into the safety space and look at object detection and 360 cameras and allowing a machine to operate on its own. And Caterpillar has some things on the soil compaction side where we do have a semi-autonomous soil compactor, so it does still require an operator, but the machine drives itself and, you know, gives you better pass coverage and better efficiency. And then, yeah, perfect. There's a link there. There are other manufacturers out there that are working on fully autonomous paving job sites. You know, so you can imagine the consistency that you can build into that entire process when it's robots essentially deciding what to do and when. So yeah, I think we're all heading in that direction. It's just a matter of how quickly we get there and what the final solutions look like.
Very good. Thank you. I'm glad you stuck with us, Brian.
Yeah, absolutely.
So I assume that it would be easier if the other things are also autonomous too. I think I've heard that about driverless vehicles. It'd be easier to implement if it was just you knew all the cars are autonomous versus having to deal with uncertain human movements. So
yeah, absolutely.
Yeah. So that's great to see that there's progress in that area too. We're pretty slow in the paving industry to accept change, but I'm assuming with autonomous, once that starts happening, that might go pretty quick. So thanks for sharing that link too, Kevin, with an example of the autonomous rollers on a highway project. It's been great discussion. I do want to open it if anybody has anything else to say or ask of our vendors while we have them. Or any of the vendors, if you have anything burning question you want to get off your chest.
I might have this is Jacopo from 3D Radar. Just a comment since we are going towards the end anyway. You know, I just want to say that we were joining late in the entire concept for the R06C, and then, you know, whatever happened as a result, and satellites, etc. And that was, you know, because we were pushed by people like Kyle and others like him, but you know, we were pushed to try and find a solution, and yeah, I'm grateful for that. Apart from it was a lot of fun, of course, to work on this kind of stuff, and I would invite, you know, since we have a little bit of a different system than the others in many different ways, and those we are not trying to find the same solution. Really, it's very little overlapping, I believe. I would really invite everybody to reach out and give me a little bit of feedback. Somebody has already done it. I had some great conversation with Rich from Alaska, for example, Rich Gissel. And please do get in touch. It would make for an overall better technology. And we are at the point where we really need some feedback regarding, you know, usability and user scenario, et cetera, et cetera. So, yeah.
Yes, that's great thoughts, Jacopo. And it ties into, I think, how we can end this one is that, you know, basically this is hopefully, I think, the start of a user group where we invite all the vendors in the industry, agency, academia, contractors, consultants, and let's all talk through these different chicken and egg scenarios. And it does help when you at least get the thoughts of what these different stakeholders have at the moment. So we'll definitely look at supporting these type of events through the pooled fund, or even after the pooled fund ends in the future. So I really appreciate the vendors taking the time and answering questions, and I think this will be a great starting point to continue these maybe a little bit more frequently now that we're trying to get closer to deploying the technology in a more widespread way. We will not have this type of a meeting in TRB 2022, but I do think that's a good idea. I mean, it's tough with everybody's schedules being so busy at TRB, but that might be a good venue for 2023 for something similar. So with that, I'll thank our vendors and thank everyone for their time, and we'll talk to you all later.